Okay. Just kidogo. Okay. Microsoft Learn is a program for students. It empowers students in the fields of technology through events, workshops, and it provides like a lot or it creates learning resources for you to access the resources. Maybe there'll be a link shared in the WhatsApp group, but you can go to microsoft.com/learn and you'll get to see the many learning paths you can see from that website. Yeah. Okay. Some of the technologies can explore in this program is programming, have cloud computing, machine learning, there's AI, is web and mobile application development, and so much more. Yeah, we'll be talking more about that in our Microsoft Learn WhatsApp group. Um, yeah, if you have any questions, you can send about this program. And yeah, there are so many opportunities in Microsoft, like the Microsoft Learn Student Learn program by itself, and yeah, you'll get to learn more about this. Yeah. Hello, can you still hear me?
Yes, we can hear you.
Okay. I think that's all. Collins.
Hello. I think next we have Cliff. Cliff, are you in the audience?
I hope you can hear me.
Yes, we can. Hello, Cliff. We can hear you.
Okay, you see my screen.
Yes, we can see it.
Okay. Right. Can you see my slide? I don't know what just happened. Okay. Because my slides took me quite a while to load, but yeah, I am a student at Moi University. I am Microsoft Student Learn Ambassador, and I so the program student and technology already done. to better their. I'll be talking about introduction to Python. Python. What is Python? What can Python? Why Python? So Python is a popular programming language. How these languages? It's object-oriented. What do I mean by object-oriented? So in the way that you do your work, it can be in steps, one step to another. It was created by Gil van Rossum and released in 1991, and it can do software development. You can, I mean, things to do with databases and so this is step scripting, which is building a whole system. So what explained a bit about that, but I explain more. Python can be used to create web applications. So what do I mean by web applications? So by web applications, I mean like a full scalable website, which has a front-end part, which is where the user interacts with the user interface, and also has a backend, which is the server side where information and data can be stored. The connecting databases, I mean, it can read databases and modify those files. It can also handle big data, like smart problems. So as I said in the previous slide, it's used in software development, which are things like web applications, which is the database files, and it's also used in Hatcom. Okay. Why Python? So I believe most of the you might be somehow familiar with one of the programming languages. There are so many out there. There's Python, the C++, C#, and like what's the thing with Python? Python works on different platforms. By different platforms, what do I mean? I mean it works on Mac, it works on Windows, it works on Linux, and just having that multi-platform type of language would benefit. Now, apart from that, Python has a very, very simple syntax. It's similar to the English language. It's, let's say, it's the English language programming, because if you look at a Python code, can make some sense out of what is happening in that code. So the syntax and how it's written, it's very similar to the English. Now, because of the simple syntax, it can be easily interpreted by humans, but also easily it's somehow, I can say, an interpreted type of language, which makes sure that the machine quite understands it very fast and any Python command faster. As I had previously said, it's object-oriented, meaning it's procedural in how it's done. Apart from that, syntax, writing fewer code. So the code that you write in Python compared to other languages, you notice that Python is very little code is written to do the other languages. So that's just a basic intro on Python, what Python is, what Python can do, and why Python. So just a brief wrap up. Language object-oriented. Python is multi-platform. It has to understand. It can do a hardware development to server side to system scripting, and so yeah, I think That's just a brief intro on what Python can do and why should you choose Python. Okay.
That's great, Clifford. That's really. Does anyone have a question about Python right now to Clifford? Ask Clifford. Anyone?
Okay, I didn't hear you quite well. Sorry.
Am I? Has a question that they can ask right now.
Okay.
Yeah.
Take any questions from any person. Really sorry for noise in a public space. I believe you heard me quite well.
If there's no question, we can move to the next. Frank, can you share the slide? Hello, Frank.
Yes, hello.
Can you?
Just a minute.
It's okay.
Is
Thank
it clear
you.
now?
Yes. Can you hear me clearly, or am I breaking?
It's clear, you're clear.
Yes, you are clear.
It's okay. So I'll be taking you through data science and machine learning, the big picture, just an introduction of what we will be going through in this session. And I'll only take like only like 5 to, let's say, 7 minutes. And so, Frank, can you go to the next slide? So I'd like to describe data science with a picture or an image of this guy pointing to humongous data. And data science, as we know it, is just a study of data itself, and it involves developing methods of recording, storing, and analyzing data to effectively extract useful information. So, like Google, what Google does with every key press, with every search you do, they take in your data, and by 2005, Google had predicted and said that with every like the first 3 keystrokes, they could know what you want to type in your next it's like they already know what you want to do. So as to describe data science is like processing this data or information that we have every day, or text that we use, or speech, or any pattern, the weather, everything, to just generate a pattern. If it rains today and it rains tomorrow, if we say we're using data science, we can use this data to almost know that certainly in the next day it's going to rain. So as a science, data science, I'm going to repeat the statement, is the study of data involving developing methods of recording, storing, and analyzing data to effectively extract useful information. And in this, we use the analytic applications, and data scientists can then review the results to uncover patterns. Next slide. So also here, we'll be talking about machine learning. And machine learning is a subset of AI, artificial intelligence, where we teach the computer to learn. Hello? Can you hear me well? I can hear someone.
Yes, we can still get you.
Yeah, so as I was explaining, it's the part of AI where we try and teach the computer to be human. That is in simple words, trying to teach the computer how to learn on its own. As you can see in the image, it's like, well, if you have not learned by now that I want what I want, I am not going to tell. Oh, the next slide, please, Frank. They're just the one above you, the animated. Yeah. So that is like the simple definition of machine learning. It's like you're trying to teach a computer without teaching a computer. You're giving it the power to teach itself. That is like the simple definition of what we're trying to do. Like you just give it data and it discovers the patterns, just like a human baby or a human child born in this world without knowing anything. But as the child grows, they consume a lot of data, and in the end, they get to do things because of the patterns they have learned. Like you wake up in the morning, take breakfast. When it gets to noon or lunch, you take lunch, how to eat, how to walk, everything. As they consume data, they learn and do things the way they're required to do. Okay, you can go to the definition. Wrong. Oh yeah. So machine learning is a branch of AI and computer science which focuses on the use of data and algorithms to imitate the way humans learn and improve its accuracy. Okay, you can go to the next slide. I think that's the end of it. Frank, just we can send. Yeah, that's the end of it. Thank you. I think machine learning itself is really fun and interesting for those who are going to take this path and start learning. It is a field that is growing rapidly, and since everyone now knows, let's say, how to code, this is the future for those who want to know how to code and teach computers also how to code, maybe, so that it gets to a time when instead of you feeling like a computer is taking your job or AI will take your job, you will be the one programming that AI so that you have job security for life. Thank you. Frank, you can take over.
Yes, thank you, Collins. Yes, and so far we've looked at an introduction to programming itself in general. And from Cliff's presentation, we saw that programming is just a way in which we define or tell our computers what to do, how to perform specific tasks. We give them an input, and then we write a program, which is basically a set of instructions to tell the computer how to handle that data and give us a desired output. Yeah, so generally that's what programming is, and we've also seen why use Python. Yes, Python it's very versatile. It has many and diverse applications in the field of data science and machine learning, in the field of software development. It can be used to create web applications and application programming interfaces. Yeah, Python can also be used for scientific analysis and computation. With Python, you can be able to do interesting things. Like, for example, if you are in the field of engineering, you can use Python for simulations, for intensive computations as well. Yes, and our primary focus for this presentation is to see how you can get started with Python, its fundamentals. Yes, how you can get started with its fundamentals or basics so that you can now go into a specific area, for example, machine learning and so on. So in this next part, I'll be taking you through the basics of the Python programming language. We'll be looking at its syntax, some of its rules, some of its features, if I can call them that. Yes, we'll be writing some code, running it. Yes, as we learn more about this language. So just a moment. Can you see my screen?
Yes, we can see it, Frank.
Okay, so the first question obviously would be, how do I get started with Python programming? Now, there are various options to get started with Python, but I'll show you one way, a common way, especially for data science. We use a simple installer. It's called Miniconda. So here's the website. I'll be sharing the link in the chat. So if you come to this link, just search for Miniconda, yeah, Miniconda, and among the results, you will find their website. So go to the installing section right here, and you'll find various installers depending on your operating system, your version, 64-bit, 32-bit, and so on. So choose an installer that's appropriate for you. So for example, if you are running Windows 64-bit machine, you can install either Python 3.8 and 3.9. Okay, Python has versions. So for example, we have Python 2, which is an older legacy version of Python. It's no longer like in mainstream support. So for this tutorial or for this event, we'll be learning Python version 3 and more specifically version 3.6 and so on. Yeah, so you can find these versions here. So what differs between these versions is just the features. In newer versions, we have more features being added. Yes, and we also have maybe some issues being resolved in newer versions. Yeah, so the latest version at the moment I think is version 3.3 what? I think it's not beyond 3.9. Yeah, so you can download the installer right here and just go through the installation process. It's just like a normal PC app, just install. And okay, once you install the Miniconda, or rather once you install Python using Miniconda, you should have a program called the Anaconda PowerShell prompt. The Anaconda PowerShell prompt, and once you have it, just open it. It's more like a command line tool. And now I'll give you a few commands to run, but basically the first step is creating an environment. I wish we could do it together. The only problem is that it can take a bit of time. Are you still seeing my browser? I'm still in my browser.
Yes.
Okay, so after downloading and installing Python using Miniconda, let me share my entire screen so that I can show you where to go next. So after running your installation of Python using Miniconda, you should have Anaconda prompt and Anaconda PowerShell. Here we have Anaconda PowerShell prompt. And so once you open it, it's just like a command line tool, the same way we have CMD for Windows. So from here you can create your folder, a folder where you want your project to go or to be contained in. So it's taking a bit of time here. It's taking a bit of time, but I can show you another instance I have running already. So, and then, okay, after installing and running the Anaconda PowerShell prompt, just navigate the folder where you would like to have your project or to save your code. And then you run this command, conda activate, and then choose any name for your project. It creates an environment for you. So an environment is just basically, so yeah, for here, I also have one. So we just increase my font size. I'm just demonstrating how you can go about this. So I can create a new folder here. I call it project. Oh, sorry, I haven't created it. Show you how to get started. And navigate to that folder. Now, in this folder, there's a command installed already. It's called conda. And run conda activate. And you can say, for example, my project. So what conda activate does basically, it just creates something called a virtual environment for you, where you can now run your Python code here. You can install packages. I'll show you how to go about that. So just run conda activate. Actually, I do not think that's the exact command. Sorry, it's conda create. First of all, yeah, you create, and then you provide the name. So the guidelines are here in the website. So here installing, so here you can create name, yes. So conda creates the name of your environment. It might take a bit of time, but yeah, it's setting up the environment. So this environment is just a workspace for you where you'll write your code. So let's give it a moment. And once you create that environment, you now run that activate command. Select yes to proceed. So now here you can activate. This is the command here. Conda activate project. So basically the name you chose for your environment. Now here it changes. So if you just notice, and then can you still see my command prompt and everything?
Yes.
I hope you can. Okay. So here you can now see that it changes so that the prompt itself, we have my project. Now you can install something very important called Jupyter. So we can do conda install Jupyter. So what's Jupyter? So Jupyter is a tool. It's very common in data science. It's like a notebook where you can write your Python code as well as documentation or notes, and you save them together. So a Jupyter notebook can contain your data, your project notes and documentation, as well as the code itself. So let me install Jupyter. So these are the steps to get started. I didn't want to assume it. It might perhaps be challenging if you're doing it the first time. So I wanted to just show everything here. So it also takes a bit of time. It takes a bit of time. So while it installs, we'll start going through now the content itself. This was just to help you get started. So after installing Jupyter Notebook, which it's currently doing, after install it, there's a command you run. And after you run that command, okay, it's still installing. After running that command, basically it's going to open something that looks like this. So in your case, it might be empty. So you won't have any of these files that you can see here. You know, some files are visible, but if you just install it, if you just install it, then there will be no present files. So, okay, the first thing, so allow me to now present the screen itself. I hope you can now see my browser window again. The presentation is
Excuse me, Frank.
Yes.
You've gone too fast.
I've gone really fast.
Yes, because right now is when I was installing my Miniconda, sorry. Then they want some verification details.
Okay.
Yeah, so you can indulge as a minute.
Oh, it's okay. It's okay. Yeah, it can take a bit of time. So for me, I had it pre-installed already. So I just wanted now to show how to set it up. If you have any,
So like I also,
especially,
sorry,
uh-huh.
I also need a direction. Is it Anaconda Nucleus?
Okay, Anaconda Nucleus is just an organization that's part of Miniconda.
Mm-hmm.
So yeah, but there's also another one called Anaconda. It's also another organization. They have their own tools, but Miniconda is a bit smaller. Like the package itself, Miniconda, is about 80 MBs or 79 MBs. There's also another one
Yes.
called, sorry, Miniconda is smaller, but Anaconda happens to be a bit bigger. It's about 500 MBs. It has so many other packages for machine learning that we won't be using in our application. And that's why I preferred we use like Miniconda, like the smaller version, the mini version of the main installer, which is Anaconda. So, and when you're installing it, just choose the default options. Choose the default options. Yes, and
Okay.
continue with them. So don't
Okay,
change
thank you.
anything to the configuration. Yes, okay.
Okay.
So for me, it's still installing Jupyter Notebook. That's where I left it. But after you install, you should have something that looks like this, what you can see here on my browser. This is now what's called like, it's the Jupyter Notebook like working space. So here you can create Python files. And to create a file, just click on new, then Python 3. So it creates something called a Jupyter Notebook for you. And basically here is where you now add your code and your documentation. So in this section, we'll be going through a few of the notebooks I've created. So to start, just a minute. Okay, so this is a notebook that I've created. And in this notebook, we're going to be going through the basic data types in Python, as well as variables. So you can see we have some notes and also some code. So a notebook basically has cells. So everything you see here like is in a cell. So this is basically a cell. And your first line of Python code, that's the title. So right here, let me just zoom in a bit. Yeah, let me zoom in. I hope it's clear to everyone. So here, line 3, we have some Python code, print hello world. So what this is basically, print is a built-in function and it displays a message on the standard output or the screen. So I use the word function, and assuming that you've not done programming before, you may not be knowing what a function is, but a function basically is an entity or a unit of code that performs a specific operation in our program, and we'll learn more about functions later. So, okay, to create a new cell, or to create a new cell notebook, I just click on a current cell and I press letter B. So that creates a cell below this. And if I can just run the same piece of code, write print hello world, and it does the same thing. Basically, it just writes hello world in our screen or on our screen. And okay, it's taking a bit of time. I'm not sure why that is. Okay, but this is the output we should expect. And this first part will be talking about variables. So variables are a very important concept in programming. And variables are basically named locations that store data for our program. So you can think of variables as containers that hold some data. And to create a variable, this is the syntax in Python. We have something on the left. It's called an identifier. So right now you can see I have highlighted, this message. So message is the identifier or the variable name. And then we use an equal sign, which is basically an assignment operator. And then we give the value on the right. So that's how we create a variable. This is the syntax. In this case, we are creating a variable called message, whose value is hello world. And once we create variables, it's a bit rainy where I am. I'm sorry for any noise, but I'm trying to be as loud as I can. So once you create a variable, for example, in our case, we created message, we can now reference this variable so that we can get that value that it contains. So that's the concept of variables, just holding something or some information to be used in your program. So here we have our message variable, which is hello world. So when we run print message, we basically get whatever it contains. And we said print is just a function that prints an output to our screen. And to run a cell in Python, so once you've written some code, you can just run a cell. There's a button called run. I'm hovering over it right now. Just press on it and we'll go to run some code. Yes, and variables can also be reassigned. That is, we can change the value of a variable to be something different. So for example, the same message, which is the name of this variable or the identifier, we can change it to something different. And when we reference it, we now get that different value that it now contains. And just a moment, there's something. I think I'm having a bit of a problem with my notebook. I'm not able to run the cells. I'm not sure why that's happening. Okay, but let's just go on. So now that we've talked of variables, we've said that these variables contain data. Now that data can be of different types, and Python has various data types. So a data type is basically, what type is that data that you have in the variable. So, and every value in Python has a type or a data type, and there's a special function again called type right here, type. Yeah, we can use that function to know which class a variable or a value belongs to. So we have simple types and more complex types. So for the simple types, we have the first one is numbers, and numbers, like as we know them from math. And there are different types of numbers in Python, or there are different types of numbers. We have ints, like integers. We have floats. So int, the int type represents integers. The int type represents integers or whole numbers. They have no decimals. Then we have the float type. They represent numbers that have decimals, also called fraction parts. I've given some examples right here. So a 1.8, 2.0, so long as it has a point or a decimal, then that's a float. And if it's a whole number with no fraction, that's an int. And these are just the names of these data types. And we also have another type for numbers called complex. So these are numbers with real and imaginary parts. If you've done like a bit of advanced math, maybe you've come across complex numbers. You might not deal so much with them unless you're doing some scientific programming, but it's good to know that it also exists. So here I have some cells. So right here we have some code cells where I create a variable, I give it the name num1, then I assign its value using the equal sign to 5. And if we print its type, because if we, when we run type, it returns the type of this value, or the type of the data this variable holds. We get it's an int. We get back an int, so it's an integer. So here we have another number, num2. So we create another variable and we assign its value to 22.5. It's of type float. And here I create another number, num3. Its type, it's complex. So this is just to show you what we get when we run this. So this is the output when you run this cell, complex. Yes, so that's it for numbers. We also have strings. So a string basically is a sequence of characters within quotation marks. We can use single quotes, double quotes, or triple quotes. So previously we had this variable that we created. Our first variable was message. So this is a string, for example. So anything within quotes is identified as a string. So we are right here. So for example, when we print that type of message, we get that it's a string. So I hope you're becoming more familiar with this Python syntax. So these are functions, basically we are calling them. Type gives us the type, and print just prints that result from whatever we get by calling type right here in our output. So we are told that it's a string, str, standing for string. So here we also create another variable called caption. We assign its value to this sentence. And when we print it, so basically it's a reference to this string, so that we get back that value. And you can notice that here we're using double quotes, so it's also allowed. And we can even use triple quotes. Now, triple quotes are important or useful when we are creating multi-line strings. Multi-line strings are basically strings that take up more than one line. So for example, here I have a string or a variable called poem, and it contains a few verses or a few lines in separate strings. So I use a multi-line string to be able to create new lines easily. Yeah, so for strings that take up more than one line, you can use triple quotes. Yeah, and when I print poem, I basically get the lines. We also have a useful function in Python. It's called length, or len. It's a function that gives us the length of characters in a string, but it depends on what is applied to it. So if we call length len, we just say len parentheses and then our variable name, which in our case is a string. Here we have a variable called month with a value April, and when we call len on it, we get 5. So len basically gives us the length of characters in a string, and the length basically means the number of characters it contains. So in this case, this string April, which is the value contained by that variable, has 5 characters. Called length 5. Yes. Okay. Strings also support something we call indexing. So indexing basically means accessing values from their index. Now, every character in a string has something called an index. So an index is just like its position in that string or what. So every character has an index, and that index basically is like a position. So the first character has the index 0, and the second character has index 1, and so on. So for example, if we look at here, this variable, month, Python, sorry, April, month, April, when we reference month, the variable name, and then we use this special syntax, square brackets, like some square brackets, and then we provide 0. So this 0 now is an index, and it gives us the first character. If we call 1, it should give us the second character. For some reason, my notebook, I don't know, it seems to have incoming may hang. I can't really get, whenever I run, I'm not getting the output. Something is not okay, but it should ideally give us, here it will give us the second character, which is P. And are we still following? Am I clear? Hello?
Yes, you are clear.
Oh, I'm clear. Thank you. Thank you for the feedback. I hope I'm not going too far or too fast rather, or too slow. Yes, and just allow me
But
to
Frank,
troubleshoot.
hello.
Yes, please.
I hope
Hello?
you will provide the recordings as well.
Yes, I will.
Okay, thank you.
Okay, you're welcome. I'll provide this recording so that you can go through more slowly in your own pace. So give me just a moment. Allow me some time to just restart my notebook, my kernel, so that I can resolve that issue. Can you still see my browser? I've just restarted everything so that I can now have cells that are actually working. Just a moment. Okay, it's still starting, but in the meantime, I remember we were installing Jupyter. So when I began by showing you how to get started on your own, like how to create your own environment using Conda Create, how to activate it. So before this session ends, I'll show you also how you can create your own notebook, your own Jupyter notebook, where you can now run your own code. You can see my browser. I hope we are still together.
Yes.
So we together. Okay, so can you see my browser, like my browser window? So I hope you can see it. Okay, thank you so much. Thank you so much for that. So we've gone through most of this. I just had to restart because it didn't seem to be working. There seemed to be an issue, but now it's okay. It's resolved. So we were talking about strings and indexing. So now I was saying that every character in a string has an index, and we can access, you know, the index of a particular character using this kind of syntax. So for example, if I run month 0, it gives me the first. If I run month 1, it gives me the second letter, and so on. And one thing about strings is that they are immutable. What that means is that we cannot change the individual item or character in a string. Like, in other words, string do not support string reassignment. So if you try, for example, to change the first letter to B, so you say the first letter is A, and maybe you think, okay, perhaps I can reassign it to B, to be B. It won't work. It's an invalid operation. So in other words, you can't run something like this. You can't attempt to change an individual character in a string. They are immutable, and if you run this, you get this kind of error. So far we've looked at numbers, then now strings, then quickly we'll go over booleans or booleans. So booleans are types that have two possible values, true or false. And these two are special keywords in Python. They're used to perform conditional logic or to perform code under specific conditions. And here we create two variables X and Y. And this is how they look like. You can even see they have a special kind of highlighting, some green kind of highlighting. That shows you that it's a reserved word or a keyword in Python, or it's basically a word that the Python interpreter has given a value or attached a value to it. So here we have X is true, Y equals false, so we assign Y to false. And if we check their type, both of them, we just run this cell. You can also press Shift and Enter to run a particular cell, Shift and Enter, and you get bool. So this is short form for Boolean. They're very simple, but also very powerful when it comes to programming. They're an important concept. And when we look at conditional statements such as if and else, we'll make use of Booleans again. So, and then those are the simple types: Booleans, strings, integers, floats, and complex numbers. Now we have data structures. These are more complex data types, not complex in the sense that they're hard, but rather they can contain more than a single value. So they are more of a collection of values. And we have 4 of them in Python. We have lists, sets, tuples, and dictionaries. So let's start with list. So a list in Python is a collection or a sequence of items. They are created using square brackets with comma-separated values. So remember, we're still talking about data types. You know, what are the various ways we can represent data in our Python program? So in this cell, the one that's currently active, so we have numbers equals something to the right. And this something to the right is basically a list of numbers. Like we have some brackets, some square brackets, and then some values separated with commas. So that's the syntax to create a list in Python. And if we check its type using this function, and then we print that result, we get that it's of type list. So numbers is a list. These numbers, it's a list containing numbers, and each item in a list can be accessed. Like it's possible to access the individual items in a list by referencing its index, just like we saw with strings. And lists are zero indexed, meaning the first position is 0. So the first item is index 0, and the second item is index 1, and so on. So for example, if I print numbers 0, I get the first item, which is 1. And for example, if I print numbers 4, I get like 0, 1, 2, 3, 4. The fifth item is index 4. So that's what I get. So just it's important to know that these indexes begin from 0. And Python has a unique feature compared to other languages. We can also use negative indexing to access elements from the end of the list. So for example, if I say numbers -1, if you can see this cell, numbers -1, we are able to access the very last item. So 0 stands for the first item, -1 is the index of the last item. So we can use negative indexing to access elements from behind the list or from the end of the list. If I do numbers -2, it gives me 4, the second last item. It's just something important and very useful at times with Python. And we can also perform an operation with list called slicing. This is where we extract a range of values from our list. So for example, in this case, we still have that numbers array. And perhaps I can just modify this cell a little bit. We can print numbers just to see its value again. And I'm not sure whether I ran it. Okay, I did. So right here in this cell, so we have numbers. So that's our array. I'm just printing its value to the standard output. Now here, we are performing an operation called slicing, whereby we use square brackets. We give a start index and an end index and a step size. So what this helps us, it helps us to get not just one item at a time, but a group of items. So if I run this, it gives me between the numbers that are between these two indexes. So between 0 and 3, but not inclusive of the end index. So this is going to give me index 0, 1, and 2, which are these three numbers, 1, 2, and 3. So as you continue practicing Python, you'll get more and more familiar with that. So here's another example of slicing. So here we're calling numbers. We're passing 1 as the start index and 3 as the end index. So this will give us the items within that range, that is between 1 and 3, but not including 3 itself. So basically, this gives us 2 and 3. So we can see that 2 is index 1. So this is the first index and the second index. Yes, it doesn't include the final index, which is 3. It's just these two. So the items that are index 1 and 2. So basically, slicing just helps us to get a portion of a string. Also, just know that they are optional. The start index, the end index, and the step, they are optional. For example, in this case, I didn't provide the step size. The default is 1. So if you don't provide, it just skips 1. I'll show you what step size means in an example down here. But step size is to show just how should it skip as it's slicing the list. So here also we have another example of numbers. We provide 2 as the start index, and then a colon. So that means for the others, for the end index and for the step size, just use the default. And so this is going to give us a section of the array from index 2. So 2 is our start index. So from index 2, so from 3 going onwards to the end. So it gives us those items. And this is another example whereby we ignore the start index and we just opt to give the end index. So this gives us all the elements that are before index 2, that is 0 and 1. So in our case, it's 1 and 2. I hope it's not very confusing. And then here's another example of slicing. So here we don't provide the start index, we don't provide the end index, but we provide the step size of 2. So what that simply means is that it goes like it basically, it just, instead of making a step of 1, a step of 1 basically gets all the items. But if we use a step of 2, it skips alternatingly, so that we have 1 and then 3 and then 5 as our result, as our output. and they're very useful. Slicing is very useful. And here's one last example where we provide a step size of -1. So basically we skip the. So let me run this cell right here. So again, we have that variable, that list. We skip the start, the stop, and we just provide -1, the step size. And this basically gives us the items, but reading it from the last item going in reverse. So essentially, it ends up reversing our list. So it's just a simple way to reverse a list in Python. Like if you want to write the elements from backwards, just use slicing and then provide a step size of -1, and it will read them right from the last element going to the first in reverse. So it ends up reversing the list. It's also something important to note. And lists are mutable, so meaning we can reassign the values in a list based on their index. So for example, let me just print that value of numbers in this cell. Numbers. So if I run this cell, so the code in this cell usually runs sequentially, like from top to bottom. So at first, numbers is still the same way we created it, 1, 2, 3, 4, 5. And then right here, this line that I am highlighting, in this cell 10, it has a number 10. We see that the first item, numbers 0. So we access the first item and we can change its value by saying it's equal to something, then we give that value we want. So we change its value to 24. And now when we look at the resulting list, we can see that the first value, index 0, is no longer 1, it's 24. So that's basically what we mean by reassigning. Yeah, we can change a specific item within a list, but remember we cannot do the same thing using a string, but in a list we can. We can also change more than one values using slicing. So for example, I can just do numbers. I provide the range that I want. So in this case, it's index 1 between the first index and the third index, but just before. So that gives us 2 items, index 1 and index 2. So I'm changing them. So if I run this cell, you can see that, well, previously index 1, index 2 were 2 and 3. Now I've reassigned them to 48 and 96. So I've basically given them a new value. There's also something called unpacking or list unpacking, whereby I'm just giving the values like this, but don't worry so much about it. We'll talk more about that, but this is basically called list unpacking, whereby it's like the program is, or Python is unpacking these values and assigning them individually to the elements in the list. And lists can also have mixed data types. For example, it's not a must that the values in the list be of the same type. In this example here, we have a list called items, and it has one value that's a string, a boolean, and a number. But okay, this is not always a good thing to do, like in practice when you're writing actual code, because it can result in some unexpected issues if the type is not the same. So in most cases, you just want your list to contain the same data type. So here's an example of that, whereby we have a list. We create a list, menu options. We assign its value to a list of strings. They're here. So we can say we have a list of strings. And when we just return its value here in the cell, menu options, when we just inspect its value, it's a list of strings. Yeah. So in most cases, you want the items in the list to be of the same type. And something else, we can also use the length function to get the length of a list. It's an important function when working with list. The same way it gives us the length of a string, we can also get the length of a list. And the length basically means the number of items in the list. So for example, we had our numbers array. It's still accessible to us. It's because we ran that cell, so we still have it in our program's memory. So here numbers, when we call len on numbers, we get 5. So it had 5 values, and when we just inspect, there are 5. So many options. For example, this list, when we check its len using this function, we get 4. So len is a useful function to give us the length of a list. Just one final thing to mention about lists. Lists can also contain other lists as elements, and these are called multidimensional lists or matrices. So basically, whenever we have a list containing other lists as its elements, we call that a multidimensional list, and it's very common. You see that a lot when working in data science, or we're creating data science applications and so on. So here we have an example of a list. We create a list called coordinates, and we can see its value we have lists, and each list has 2 items. So you can just think of this variable being a variable that holds pairs of coordinates. And you know, coordinates, for us to represent a coordinate, we need the longitude and the latitude, or the latitude and the longitude, whichever order. So this is just an example of how we will hold such kind of information in our Python program. We create a list, and then as the items, we have other lists that hold 2 values each, for the latitude, for the longitude, to hold a pair of coordinates. So we basically call this a multidimensional list. And for example, if we were to access the first item, we see that it's 37 and 31. Basically, the first item is another list on its own. Now, supposing we want to get an individual item in these nested lists, so we have first of all to access that list. Let's say, for example, we want to get this 32. We just reference coordinates, our identifier or variable name, and then the index of this list that it is within is index 1, like the index is 0, 1. So this is index 1. And now the index of the value itself inside that list is 0. So you see how it's like we're using 2 square brackets. So the first square bracket like basically takes us to the index of that list in the main list. And then the second square bracket now gives us the value itself. So 32. If say, for example, we want to reference 71, how will we do that? So let me add a new cell. I just click here and I press B. So if to reference 71, just do coordinates. So it's index 2, right? It's index 2, index 2. So index 2, basically this pair, this item here, this item is index 2, and sorry, it's index 1. I mean, 71 itself is index 1. And if I run this cell, then this cell, it will give me 71. So that's how you access items in multidimensional lists. The next type. Oh, okay, something just to note, strings also support slicing. The same thing we have seen in lists. We can also slice or basically read just a section of a string. For example, here we have a variable called language. It's a string. I mean, its value is Python. We can read the first 2 characters by basically using slicing. So by providing a start index of 0 and an end index of 2, we're able to get the indexes 0 and 1, or the items within the indices 0 and 1. So there we have py. So basically the same way we can slice lists, we can also do the same in strings. And then we have tuples. So we've talked about lists. Now we have tuples. It's also like a data structure in Python, and it contains an ordered sequence of items, just like a list. The only difference is that tuples are immutable, so you can't modify or you can't change a specific item inside a tuple. So you can't change once you create it, like you can't add something to it and you cannot change its value. So this is how we create a tuple. We use round brackets, and then we put in our values, we separate them using commas. So for example, here we have a tuple, students, its name is students. So it's just a variable, its value is a tuple, and this is how we create it. And when we check its type by simply running type and providing the identifier, we see the tuple. Tuples, okay, they support indexing and slicing just like lists. So for example, you can get the item in the first index by just running students and then 0. We can also slice, we can also basically get a subsection. For example, if I run students, I provide, this is the end index. So we leave the start index blank, we just provide the end index. So it basically gives us all the items that are before index 3. So index 0, 1, and 2. So these 3, that's what we get back. But we cannot change a specific value or a specific item. We cannot change the value of a specific item within a tuple. So if I try to reassign the first element, I simply get an error. Yeah, tuples do not support item reassignment. That's what it means when we say that they are immutable. You cannot change the values within them. And then we also have sets, another type in Python. So a set is basically an unordered collection of unique items. We create them using curly brackets, and they are unordered, meaning that they do not have, the items do not have indices. Unlike lists and tuples, sets do not have indices. And the items in a set are also unique. So sets by default, they always eliminate any duplicate values. So for example, here we create a tuple or a variable, sensor temperatures, and its value is a tuple with the following numbers. And when we refer to its type, we get its set. So set, that's the type. So the type of this value is a set. It holds a collection of unordered items. And one thing to notice is that I provide a duplicate here, 24.3. I also provide another 24.3 right here. But when I print its value, print sensor temperature, you realize that the duplicate item has been removed. We don't have it. We only get the unique items. And you can also notice that we get items in a different order than the one we created it. So that's what we mean when we say they are unordered. So they have no particular order. The elements are not stored in any particular order. The way they are stored in lists, based on their indices. And okay, maybe just have a question about sets. Okay, just supposing we were working on a project, like an IoT project, and that project. Hello, we're still together. I'll try to hurry very quickly.
Yes. Yeah, together.
Okay. Assuming we're working on a project, and that project basically reads sensor data, temperature data from a sensor, and sends them to a Python API or a Python backend that we have created. So do you think a set will be the best data structure to store such a value? Do you think we can use a set in that case, whereby we're using a set to store data that comes from a sensor? Okay, for me, I would say probably not, for a few reasons. The first thing is that there's a likelihood that we can get similar readings from our sensor. And when we store them in a set, the duplicates will be removed. Okay, and also remember that items in a set are unordered. So we might not get them in the order that they were actually recorded. So, and also something else about sets, they do not support indexing and slicing, unlike lists and tuples. So because they are unordered, items do not have indices. So for example, if you try to read the first value, you simply get an error. So sensor temperatures, assuming it's an array, I try to get index 0, I basically get an error. Yeah, you see it says set object is not subscriptable. You cannot get items based on their index because there are no indices at all. Okay, then the final one is dictionary. I know we've taken so much time on the data type section, but once we are through with this, then we'll be able to go on very quickly. So a dictionary is an unordered collection of key value pairs, and the values are accessed using their keys. Let's just look at an example in this cell. In this cell, we have a dictionary. This is what it looks like. We use braces just like sets, but now we provide keys. So we provide a key and then a colon and then a value. So the key is a string. The value can be any data type. So for example, here we have name, mark, age. That's the key. So it starts with the key first and then a colon and then the value. So the value can be any data type. So, okay, so this is another key. Its value is a string, and another key, its value is a boolean. So the value can be of any type essentially, but the key is a string. And if we check its type, the type of this variable, we get dict, short form for dictionary. We can also access a value from a dictionary by just referencing its keys. So this is the name of this variable is user profile. So that's what we use, user profile. And then I provide name as the key, and it gives me the value within that key. And we can also reassign a value. For example, here in user profile, we have a key called county. We can change its value to something different. So in other words, dictionaries are not immutable. Like we can mutate, we can change values within the dictionary. For example, here we reassign that county to Kajiado, and when we print its new value, you notice that county is now different. It's Kajiado. We created it as Nairobi, but now it's Kajiado. So that's what we mean by reassignment. We can also create a new key in our dictionary. There are several ways to do it, but I'll just show you one way quickly. Supposing we want to create a new key, we just use the same identifier. We provide the name of the key, like the name of the key itself, equals an equal sign and the value we want that key to contain. So for example, I create a key next key. I give it a value of an array with 2 items. And now when I print the user profile, when I just print this or display it in the screen, we can see now we have that extra value that we added. So they're also very useful. Dictionaries are very, very useful to store composite data. Perhaps even when you're working maybe with an API and you get your data in JSON. I know we've not covered it so much, but JSON is just a notation that is used to represent data. So you can, for example, look at this example we have user profile. This could, for example, be an entity in your database, and you get back something like this whenever you retrieve that data from the database. So dictionaries are very useful. They have a wide range of use cases, and as we go on, we'll be learning more and more about them. And just one last thing to mention, we can also convert between data types. Like for example, you can change in this cell, we create a variable called temp. It's a float because it's a number with a decimal point, but we can change it to an integer by just calling int. So there are functions that help us convert from one type to another. So for example, int, it's the constructor name for that integer class. And when we call int on a value that's not an integer, it tries to convert it if it's possible. So in this case, we give it a float. And when we check its value now, we see that it's 37 instead of 37.3. In this other cell, we convert. So here we have age is an integer, but we can now call float, another function, to convert its type to a floating point value. See how the decimal has been added. We can also change from an integer to a string. Yeah, so right here, this is another example. So using the built-in string function, we can change that same age to a string. And when we check its type, so age is this number here, 19. And when we check its type, we see that it's now a string. So we can also convert an array or a list, to a tuple. So for example, I create a list numbers and I can reassign. So not reassign, but I can change its type by calling the tuple method or function. And if I run it, you see that it gives us back a tuple. This syntax is the syntax of a tuple, round brackets. We can also convert a list to a set by calling the set function. So our list of numbers, when we run it on set, there we have that. We can also convert a list to a dictionary. So we just provide a multi-dimensional list that we looked at. Yes, and you can see what's happening. Clicking name, it makes it the key. Then the second item becomes the value. The first item becomes the key. The second item becomes the value. So you can also change a list to a dictionary. And you can also change even other data types into booleans. For example, you can call the bool function on an array, and it gives us false. So basically, an empty list is considered to be false in Python. An empty set is also considered to be false. Basically, any empty collection is false. The boolean value is false. But here, for example, if we try to convert one to a boolean, we get true. If we try to convert 0 to a boolean, we get false. So there are a few rules to keep in mind when you're naming variables. So it can be a combination of letters, both uppercase, lowercase, and even digits. Yes, but one thing, you cannot start your variable name with a digit. So if you create a variable, it should not start with a digit. It can have a number within it, but just not at the beginning. You can also not use keywords, like Python keywords. For example, we've looked at all these functions, for example, bool or int or list. They are all keywords in Python, and you cannot use them as your variable names because these keywords are reserved. They have a special meaning to the Python interpreter, and it just brings errors if you try to use them as a variable name. We also don't use certain special symbols like exclamation marks, dollar signs, ampersands, hashtags, and so on. So this is not a valid variable name containing particular symbols. And also, identifier can be as long as you want. But one thing to note is you always want to keep your variable names clear and also concise, so that you both yourself and other people can understand what kind of information they're likely to obtain from that variable. So let the name just be clear enough. So that's it about variables. Now quickly, we'll just look at operators in Python very quickly. This is going to be short. And Just a moment. Can you still see my browser? Because I've just changed to a different notebook. Can you see this operator's notebook? Anyone? Collins?
Yes.
Okay, thank you. So now we'll be looking at operators. These are special symbols that carry out operations in our program. So for example, we have types of operators. The first type is arithmetic operators. And from the name itself, they used to perform mathematical operations like addition, subtraction, multiplication, and so on. And it's just the same way, for example, plus is the additional operator, and it adds two operands and gives us the output. So if I run this cell, I get 6 plus 4 is 10. We can also use that plus operator on a string. And when we apply it on a string or on multiple strings, it combines them, or it concatenates them, basically combines them into a single string. For example, I have hello and then world, then a plus in between, it just combines them. We also have the subtraction operator, basically the normal arithmetic that we know, 9 minus 2 is 7, multiplication operator, you use an asterisk, a star, like that star sign on your keyboard, an asterisk. So basically that's the multiplication operator, and you use it to multiply values. This could actually be variable names. It could still work. For example, we could have a variable 2 and another variable maybe b, which is 5, and then I just do a times b. Simply I just get the result of their product. And then we also have division. We use a slash, a backslash, I think, or a forward slash. Yeah, basically this slash. I hope it's clear enough. So that just it's a division operand. It just gives us the result of dividing the two operands. We also have a special type of, now this is something important, especially if you've not worked with Python before. We also have something called a floor division. So basically this is an operand that divides, but it omits the remainder. For example, if I do the floor division of 9, I just use 2 slashes. So 9 floor division 2 gives me 4. So basically it's just going to take the whole part of the division. So if there is any fraction part, for example, if I do the same here, you see it gives me 2. So floor division, just it divides, but it doesn't include the remainder, and it doesn't round up. So it just divides and it gives you that whole part. So it's an important feature as well, floor division. We also have exponent, an exponent basically to get something raised to power something. So for example, here we have 5 exponent 2, you just use 2 asterisks or 2 stars. So it's a square, so you 5 exponent 3 is just 5 cubed. Yeah, so that's exponent. Then we also have the modulo operator, which returns the remainder of the division operation. So it's here, for example, 9 modulo 2 gives me 1. So when you divide 9 by 2, the remainder is 1. So modulo just gives you the remainder of a division operation. So those are arithmetic operators. We also have comparison operators. So here we start by creating 2 variables, x and y. So comparison operators are used to compare two values, and they give us either true or false. So in this case, if we examine whether x is greater than, so this is the first one. They are also in math, so I know you've seen them before. So this is greater than, it returns true if indeed the item on the left is greater than the item on the right. In this case, it's false because 5 is less. So here we also have less than. So in our case, yes, that's true. So they return to us true or false. So that's important. They return a value. And then we also have equals to. So we use 2 equal sign. So this is important when you're checking for equality between 2 values or variables. So use 2 equal sign in Python. So for example, x equals y, that's false. They're not equal, so it gives us false. When I run that cell, the output is false. And we also have greater than or equal to, less than or equal to, and not equal to. So if I just run these cells, this I know you're familiar with this even from mathematics, but maybe here not equal to, you just use that exclamation and an equal sign, and then you just put it in between your 2 variables, and it will be true if the values are not equal. For example, in this case, they're not equal. 5 and 8 are not equal, so that's true. So that's it for comparison operators. We have assignment operators. They are used to assign values to a variable. So we've already seen the assignment operator so far, the equal sign. We also have others that are compound operators. They can perform both arithmetic and assignment as well. So for example, I create a variable here, num. I give it a value of 10. And you can see that in this cell, adding 2 to it and then assigning that result to the value of num. So that now we get 12. But there's a shorthand where I can just do plus equals. So this is a special type of assignment operator, like where it adds 2 to your number and then assigns that result to the value so that the value itself changes to 14. We can also do the same with minus equals. We get 11. We can also do the same with times equals. So what it does, it multiplies by 2 and then assigns that result to the value, to the variable, I mean. So it becomes, so it was 11, so it becomes multiplied by 2 and reassigned as well in one statement. So here we have division equals, so it's divided by 2 and assigned that result. So it's just a simple way to both perform that arithmetic operation as well as reassignment. So also modulo equals still the same. And then finally we have operators. There are 3 of them in Python. We have and, or, and not. So basically, they perform logical operations, as the name suggests. So and, for example, returns true if both operands are true. So for example, I create a variable x and one called y, and I give each one of them a value of true. And if I run x and y, I get true because both of the operands are true. Then also have the or logical operator. It returns true if either of the 2 operands are true or they're both true. So in this case, they're both true. So it gives me a value of true. And if one of them was still true, but another was false, it will still give me true. But for and, if one of the values is false, then it becomes false. Yeah, but in or, it's still true, provided one of them is true. And then we also have the not operator. This one basically returns the complement of the operand. And okay, that's it about operators. And now to a very final section. We might not have time to cover everything, but this is just a final section I want to go through in a few minutes concerning control flow. It will be like a combination of everything that we've talked about so far, data types, variables, and operators. So I've switched, now I'm in a different notebook. Can you see this? Can you see it?
Yes.
The title is EFLs. Okay, thank you. So control flow. So control flow is all about running code conditionally, or basically creating a particular program flow, because a normal program, just runs top to bottom, like from the top of the file all the way to the bottom. But with control flow, we can skip certain sections, we can repeat certain sections, and I'll explain in greater depth what that means. So the first thing is the if-else statement. So if-else statement is used to run code only if certain conditions are satisfied. So this is basically a feature in Python and in many programming languages, and they're used together with Boolean values to create conditional logic and to write decision-driven code. So here we have this cell, the first cell, where I see I'm creating a value x and y. I'm assigning them. I'm giving them some values. So I create 2 variables and I assign a value to them. So then here I have an if. So the syntax is very important. So let's take note of the syntax. So the if keyword, and then followed by the expression. Basically the expression that is going to determine whether this code is going to run the code within this block. So here we provide the expression x is greater than y. So in this case, it's false. And what the interpreter does, it skips everything within that block and comes to the else condition. So if we just run this, we can see that if x is greater than y, then I'll print this. And if it's not, then I'll print this other statement. And in my case, we can see that I'm getting 22, which is y, is greater than 13, which is x. So to mean that this is what executed. So we start by using the if keyword. We provide the expression itself, followed by a colon, and then an indentation, a space. It's very important. That's something that's unique to Python. Not many languages really use indentations. So if it's your first time using Python, take note of that. That within that if block, you have to create an indentation, basically a space. In many cases, 4 spaces, like 4 spaces or 1 tab, or even other times 2 spaces, it depends. But you want to use tab. So basically just make sure that your code is nested within that if statement. So that's the basic syntax, and the program evaluates the test expression, and the code within the if statement will only execute if the text expression is true. And then the body of the if statement must be indented. Yes, so this is the syntax here, like in this cell I've written it's just some pseudocode to show you everything. The structure, we have the if keyword, the expression, and then an indentation, and then the statements within that indentation level, and then the else. So the else block will execute when the expression is false. So when the if statement didn't run, then the else will execute. And we can conditions by using elif statements. So here elif. So elif is a short form for else if. Yes. And this how it runs. So the condition in the if statement is first checked, and if it's false, then the compiler or the interpreter then checks for the condition in the elif block. If it's false, it checks again for another elif block. Yes, and so on until it gets to the else statement. And if none of the elif conditions or the if conditions were true, then the block of code in the else statement is executed. So let's just look at one example here. So here we have a cell. I create a cell basically. I have a value of score, and I'm running some code conditionally. So these are the, so here you can see the if statement and then the expression, the test expression. If it's greater than or equal to 70, then I'll print this. Otherwise, if the score is greater than or equal to 60 but less than 70, so these are now the expressions. Remember we saw that these comparison operators return Boolean values, and we also saw that the AND statement only gives us true if both conditions are true. So this block will only execute if these 2 conditions are true. That is, if the score is greater than or equal to 60 but less than 70. So that's how you combine. That's how you combine comparison operators as well as logical operators to create expressions, Boolean expressions. So, and we do that inside an elif block. So take note of the indentation. So if this is true, then this block will run. If this is true, if this returns true, then this block will run. Yes, and so on. So we just have like this ladder of if, elif statements. For example, in this case, if I give 70 a score, so if I give score, sorry, I think it's in this cell. Yeah, so if I give score value of 70 and I run this cell, shift enter, I get it printing out this value. And you can have as many statements within this if block, as many. So here, for example, I have 2 statements. You can have more statements, as many as possible. So this is another example, but it's more concise, whereby I'm using compound comparison operators. So basically, instead of using AND, like I am in the previous example, here I'm just chaining them. So for example, if we look at this statement that I've highlighted, so score, if score is less than 70, but it's greater than or equal to 60, then this code is going to run. That expression, or rather, yeah, that code, that block is going to be executed, the block within that elif block. And if we just test it and we run, we can see that it's true. So you can also do this in Python, whereby you have like multiple comparison operators in one statement, and they work as you would expect. And something else, we can also nest if, elif, and else statement. So here is a simple code cell that tries to determine the largest of the 3 values, and it prints it. So you can see that in this example, I am actually nesting. I'm creating if blocks within an if block. So here we have an if statement, and then the expression if A is greater than B. So if that is true, then we check whether A is greater than C, And if it's also true, then know that A is the largest. But if it's not true, then C is the largest. So I'll give you these notebooks so that you can go through the examples one by one. But the important thing to note here is that it's actually possible to have more nested if statements, and also to have a lot of to have more expressions and code blocks like within your if indentation. Yes. So this cell basically is going to print whatever is going to be the largest of these three values by just nesting if statements. Yes. And now the very last thing we'll talk about is loops, but very quickly. So loops are used to execute a block of code repeatedly, like severally. So here we have a while loop, for example. It will execute a block of code as long as the test expression is true. So in this cell, I have a simple some simple code here that will find the sum of the numbers between 1 and 10. So in a while loop, we use the while keyword, we provide the expression. So this is the expression, and it evaluates to whether true or false. If it's true, then everything here within this indentation level is going to be executed. So these two blocks of code or these two lines of code will run whenever this while loop is true. And if you look logically what's going on, I'm just checking whether num is less than 10, and so long as it's less than or equal to 10, I keep on adding to the total the value of num, and num starts at 1. And then at each point, I keep on increasing num to make sure that at some point it's going to exit 10 and the while loop is going to stop running. So it's always important to have to make sure that there is a case in which the while loop will be false. Otherwise, you might end up creating an infinite loop, like a loop that never ends. So the structure, basically, you have the keyword itself, the expression to be checked, then a colon, and then the code to be executed. And also make sure that as part of that code, you are continually like checking, you're doing something to make sure that the condition at some point will become false. So in this case, I keep on adding 1 to num so that with every run, it increases by 1 until it gets to 10. And once it gets to 10, I add 1, it becomes 11. So this condition becomes false and it's exited. This is another example to get the factorial of a number. So when I run this code, it just gives me the factorial, but the concept is the same. So while num is greater than 0, so this is our expression. This is our block of code that keeps on running as long as this is true. And once it's false, you can also provide an else statement in your while loop, and that runs as soon as the while loop as soon as the condition is false and the while loop is exited. So this is another example. I'll give you this notebook as well so that you can check out everything. So this one finds the sum of even numbers between 1 and 20. So you can see I'm combining a while loop with an if statement, and for each iteration, I'm just checking whether the value of n is divisible by 2 by using that operand operator. So if the remainder of dividing it with 2 is 0, then it's a multiple of 2. So I increase that sum over here, and then I increase n by 1 to make sure that at some point it's going to exit 20 and the loop will be exited. So you can also go through that in your own time. And then finally, we have for loops. So those are while loops we've looked at before. Now we have for loops. So for loops are used to iterate over a collection or iterable. So a collection is basically a group of values. So for loops are used to iterate through a collection. So this is what it means, like in an example. In this cell, we create an array. That's an example of an iterable. An array called numbers. Its value is this list. It's a list actually. I'm using the term interchangeably, but I basically mean a list. So here we have a list. And then I check for, so we use the for keyword for I in numbers. So what this means is that in every iteration, it's going to give us that value I that contains the element in this current iteration. So if I run this block of code, it just prints for me the values 1 to 5. So it's going through all these items. That's what iterating means, just going through every item in the list. And for each item, I just print it out. So this is the output. Here's another example where I find the sum of the elements in that list. So for each item in that list of numbers, I add it to the total, and eventually I will have the sum of all the numbers in that list. And then we also have a function called range. Range helps us to generate a sequence of numbers, and in this case we use again for I and then in range. So this one now dynamically creates an iterable for us without us having to create that list. Say for example, we want to do something like maybe 100 times. We want to run or to execute a piece of code 100 times. So for us to do that, then perhaps if we were to use a list, then we will have to create a list of 100 elements. But now using range, we can automatically create a list. We just provide or an iterable, sorry, we provide the start index and then the stop. So the start is basically where we lead start from. For example, if I provide a start of 10 and an end of 20 with a step size of 1, this is the complete syntax: start, stop, and step size. So this will print values between 10 to 19. Remember, it doesn't include the very last one. So it's between 10 to 19. Yeah, if the step size is 2, then it will go skipping. So 10, 12, 14, 16, 18. Yeah. So you can see that now within the for loop, I have an indentation where whatever I'm doing is to print each item in each iteration. So okay, that's it. Because of time, I do not want to exceed that point. I've actually gone way beyond the time I had planned. But if anyone has a question, if anyone has a particular question, something specific they would like to ask. We still together?
Yes.
Yes.
Yes, so what I can do for now very quickly is to just share with you these particular notebooks so that you can have them. I just want to send you the link so that you can go over them during your own free time.
Hello.
Hello, yes, Bruce.
And I'm not in that group. Kindly, I ask the admin to add me.
Yes. Grace, are you there? Maybe the link can be shared. So let me share the link with you. Let me stop sharing. So now I want to give you the link for the notebook so you can find them online, the ones you've been going through, and also the WhatsApp group where you can join and get more updates in the future. Just a moment. So I'm getting that link so that I can share it with you, the link for the group. Just in a moment. So I have it now. Let me show it in the chat. So yes, I've sent the link for the group in the chat.
Hey,
Yes, have you received it?
I don't know if it's my device that has a problem, but I'm not seeing the chat box.
Are you using on a phone, or are you using a phone or a laptop?
I'm using a phone.
Okay. I'm not sure what it would be. I'm not.
The
You-
button is usually next to the participants, but today I'm not seeing the button for the chat.
I'm not sure why that is. I don't know in the way I can share. Yeah, it's just next to the to the participants.
Same case here.
Okay, I'll try and maybe message you directly. Maybe what's your name on the meeting? I'll try and message you directly to see whether maybe you're going to receive a prompt to help you find the chat.
My name is Gregory.
I can't see it either.
You still can't find it. Is there anyone who has seen it in the chat? Maybe because I have already shared it.
Frank,
Yes, Grace.
It's Quincy. Unfortunately, I'm using my laptop, but I can't be able to open the chat section. It's saying that it's only available for the team members. So you
Only
can't access it.
available for the- It's saying that it's only available for the team members.
Yeah.
Oh, okay, then it becomes like really hard to pass across information. And okay, meeting notes. Maybe perhaps it's a setting that I can change, though I'm not really sure how to change that. Okay, I've sent the link twice in the chat. Okay, let me send it perhaps to you, Gregory. Let me just see if I can send it to you personally. Let me send here's a quick message.
Okay.
Have you received anything?
Yes.
Yeah, because I've started a like direct conversation with you, but now it's hard to do it with everyone. Also, so is there anyone who has access to the chat? Because I've also shared the link to the repository containing the notebooks. And if you've not used GitHub before, don't worry, just go to the interface. Once you click on that repository, by accident I've made it private, but I'll correct that. We'll do it in a moment, but I've already shared the link to the repository on GitHub. So just visit that repository name. You'll find a button to download it. Just download it. Yes, and once you download it, you can still run. You can, for example, put those files in your environment, an environment that you create. And once you open Jupyter in that environment, you'll be able to access those files. And I'll also be sharing the recording of today's meeting.
Frank.
So, yes.
Maybe if you can share your GitHub username, that would be appropriate because we can still access the chat.
Oh, yes. So my GitHub username is Frank N Mungai, all lowercase. Frank N Mungai, FRANKNMUNGAI. Frank N Mungai, all lowercase. So at least I hope you've taken note of it. Franken Mungai. So yeah, the repository will be there. Yes, and the repository name is Python Workshop. So that's the name of the repository itself. You can download the code from there. And just one last thing. So when we were starting, I remember I showed you how to create your own environment using the Conda PowerShell prompt. You know, Conda create, then your environment name, how to activate it, and also how to install Jupyter. Now, to run Jupyter, it comes with this command after you install it. Just run Jupyter Notebook, and that will now start the Jupyter server for you. And in your browser, you will be able to have the same kind of environment you saw me using. So once you run that command, it's going to create that notebook for you. So basically, to use those notebooks from a repository, you will just copy those files. Okay, after downloading the repository and everything and unzipping, just copy the files in an environment that you create. Then once you open it using Notebook, you'll have access to those files. Yes. So I guess that's it. It takes a bit of time to start, but that was the final thing I wanted to show you. Thank you so much for your time. I hope you've learned something, and you've at least learned something new. And we plan on doing more frequent series on the same. So this was just our introduction, our first one. Yeah, but we are hoping to do even more and more to explore deeper topics concerning Python, and to even start learning more in data science, you know, using libraries and packages such as NumPy, Matplotlib, Pandas, and so on, creating our own simple models and so on. So the whole objective of this tutorial was to be an introduction, but we are going to continue working on the same. We'll let you know, but perhaps in a week's time or so, or not more than 2 weeks, we will have like a continuation of today's event and so on, whereby we'll be creating more and more content towards the same. Yes, so we're working towards having some kind of a course, if I can call it that, yeah, on Python and data science and machine learning. Okay, thank you so much for your time. If there are no more questions, then I can close the meeting. Maybe any questions or last remarks?
No question.
Okay, no question.
Yeah.
Okay, thank you so much for your time. Yes, I'm very grateful. Have a nice weekend.
You too.
Same to you.